I'm Eric Lee, Director of the Kimbell Art Museum. Thank you for joining us today. This past year, we've been celebrating the 50th anniversary of the opening of the Kimbell Art Museum. One focus of that celebration has been the magnificent, iconic museum building designed by Louis I. Kahn. Over the years, we've paid tribute to Kahn in many ways, through tours, exhibitions, and publications. And while it has been acknowledged that the success of the building was the outcome of teamwork, as well as internal disagreement and eventual resolution, the special contributions of engineer August Komendant and his ongoing collaboration with Louis Kahn have not been fully explored here at the Kimbell. An enlightening exhibition at the Estonian Museum of Architecture a few years ago, and a subsequent publication edited by Carl Dag Liga, one of our speakers today, has provided rich context. Kahn and Komendant were brilliant, each in his own way. Komendant characterized Kahn as artistic and poetic. The engineer Komendant was elegantly analytical. They relished their debates and arguments as incubators for creative solutions for better outcomes. Komendant said that he had a good first impression of Kahn, quote, because he was a dreamer and so was I. Continuing, and if he followed his dreams, I also would have the opportunity to realize mine, end quote. Today's symposium will explore the creative collaboration between architect and engineer, and also the legacy of some of the design solutions pioneered in their collaboration. We're delighted that August Komendant's son, Yuri, who is also an engineer, and daughter, Marika, an architect, have traveled to join us here today. Please join me in welcoming them. It's a special honor to introduce Guy Nordenson, one of the most prominent structural engineers practicing today. Guy has championed close collaboration as an essential basis of design in his own practice, and it was his idea to organize a program about Komendant and Kahn, engineer and architect at the Kimbell. He has worked closely with the Kimbell over the years as structural engineer for the piano building, which opened almost 10 years ago and which has not had a glitch until this morning, and whose firm recently conducted a thorough analysis and upgrade when needed of the structural integrity of the Kahn building. Time permits mentioning only some of Guy's many achievements. After earning degrees at MIT and the University of California at Berkeley, he began his career as a draftsman in the Long Island City studio of Buckminster Fuller and Isamu Noguchi. Next, Guy practiced structural engineering in San Francisco and New York. In 1987, he established the New York office of Ove Arup and Partners and was a director until 1997 when he began his independent practice. He has served as structural engineer with many leading architects for over 200 projects, many of them museums. I'll name some that may be familiar to you. In Houston, the Museum of Fine Arts expansion, the Glassell School of Art, Rice Moody Center, and the Menil Drawing Institute. The Santa Fe Opera House, Toledo Glass Pavilion, and the Jubilee Church in Rome. The expansions of the Corning Museum of Glass and the Frick Collection in New York. The National Museum of African American History and Culture in Washington, D.C., and recently the International African American Museum in Charleston, South Carolina. Guy is also an educator, professor of architecture and structural engineering at Princeton University, and an author. He has had a long relationship with the Museum of Modern Art in New York as a structural engineer of the 2004 MoMA expansion. Among other projects at MoMA, he co-curated the 2004 exhibition, Tall Buildings. He has led numerous research projects on earthquake engineering, coastal resilience, and climate adaptation, and has written books on the subject and served on numerous committees and task forces relating to such issues in New York City. We're honored that Guy has taken time from his incredibly packed schedule to be with us to moderate the program today. Before Guy introduces our speakers, I'd like to say we're also very grateful for the participation of Thomas Taylor, Design Director at Datum Engineers, Dallas. Highly respected by his peers and admired for his generosity, he embodies the best practices of his profession. Guy, over to you.
Before I introduce the speakers this morning, I would like to offer some observations on the collaboration between Louis Kahn and Auguste Komendant in the making of the Kimbell. They were not alone, of course. The former director, Dr. Richard Brown, Kahn's assistant, Marshall Myers, the builder, Thomas Byrne, and of course, the associate architects, Preston Guerin, all made important and well-documented contributions and decisions. In the 50 years, there has been also essential stewards, most importantly, Larry Eubank, who is here with us today. There is a lot we can learn about the making of this beloved and iconic building by studying the broader vortex of talent and invention. But we're here to attend most particularly to the career and contribution of Auguste Komendant. The engineer Peter Rice, a close friend and collaborator of Renzo Piano's, remarked in his address on receiving the Royal Institute of British Architects 1992 gold medal that engineers are often believed to have what he called a Iago mentality. As he wrote, quote, "Iago, if you remember, destroys the love of Othello and Desdemona by rational argument, by applying reason all the way through to every act, which particularly Desdemona undertakes. In the eyes of many," Peter Rice continues, "the Iago role is the role given to the engineer in modern life and modern architecture, to reduce by reason, to destroy, or to undermine the kind of unreasonable and soaring ideas that architects may have," unquote. An excess of rationality and a focus on efficiency will strive creativity, killing rather than nurturing nascent ideas. Rice and Komendant, who both passed away in the fall of 1992, did not ever cross paths as far as I know, but it's clear to me that both thought deeply about how to balance the subjectivity of the architect with their own commitment to the creative exploration of material facts and potential expression. While Rice explored many different kinds of old and new materials and methods, Komendant concentrated on concrete, and especially precast and post-tension reinforced concrete, and at that, he was a master. Let me illustrate this briefly. As you know, the distinct formal element of the building are the 16 cycloid shells that make up the roof. These recall that great invention of Roman architecture, the arch, but with a twist. Rather than spanning to the sides like the barrel vaults of Rome, these span lengthwise as deep, thin shell beams. This was always understood by Kahn, Marshall Myers, Dr. Brown, and of course, Komendant. The effect for many visitors is delightfully disorienting. As you move across the grain of these vaults, you feel both their enclosure shaping rooms and the freedom of the open plan space. You are also constantly aware of the changing light reflected on the lively surfaces of the exposed concrete. These, to me, are like Chinese landscape paintings, cloudy and mysterious. Komendant's genius lies behind the surface. The shells are held up by cables cast inside the concrete that curve along the span like suspension bridge cables. These and all the steel reinforcement begin as lines sketched in space by the engineer and end forever buried out of sight, the sinews of the structure. Here you can see the cables, and we'll hear more about that later. To me, the challenge in assessing Komendant's creative role is that so much of what he did with concrete is by necessity hidden. To discover them, you have to read the drawings and calculations and find photographs of the construction. This is why I'm grateful to the Kimbell for sponsoring this symposium as an opportunity to reflect on the hidden creativity, to see it with X-ray vision. Perhaps we can best understand the difference between the engineer and the architect by remembering Jane Austen's Sense and Sensibility. One sister is thought to have good reasoned judgment, the other sensitivity and insight, but both have feeling, and our experience of great work, as we will hear today, brings us closer to both their humanity and our own. Today we will hear from 4 scholars giving us their perspective on the historical context and details of the creative collaboration between Komendant and Kahn. I'll briefly introduce our speakers and panelists. We will have 2 speakers and then a panel, and then 2 speakers and a final panel. The first 2 speakers will be Carl Taglia. He's an architectural historian, critic, and educator, and a member of the Estonian Society of Art Historians and Curators. He's a PhD student and junior researcher at the Faculty of Architecture of the Estonian Academy of Arts. His academic interests focus on the history of modern architecture, particularly the relationship between architecture and structural engineering. In 2020, together with his team, he received the annual Estonian Architecture Award for the exhibition Miracles in Concrete, Structural Engineer August Komendant at the Estonian Museum of Art. He is the editor of the book Miracles of Concrete, Structural Engineer August Komendant. We are grateful that Carl has traveled from Estonia, the birthplace of both Kahn and Komendant, to be with us. It is fitting that he should start us off. Caitlin Mueller, our second speaker, is an associate professor at MIT's Department of Architecture and Department of Civil and Environmental Engineering, where she leads the Digital Structures Research Group. She works at the creative interface of architecture, structural engineering, and computation, and focuses on new computational design and digital fabrication methods for innovative, high-performance buildings and structures that empower a more sustainable and equitable future. In addition to her digital work, she conducts research on the nature of collaboration between architects and engineers from a historical perspective. Recently, she has developed and tested algorithmic designs approaches for circular material use in building structures, focusing on underutilized timber resources and reassemblable concrete parts. I've had the great pleasure of following Caitlin's career since her time in graduate school and admire both the diversity and depth of the research and the clarity and accessibility of the many digital design tools that she has developed. As you heard, after Carl and Caitlin's talk, we will be joined by Thomas Taylor for a discussion on the stage. Thomas Taylor joined Frank Chappell and Associates after graduating from the University of Texas in 1959 with a Bachelor of Science in Architectural Engineering. By 1963, he assumed leadership of the company and incorporated the firm as Datum Engineers. He's the principal design director at Datum and has been practicing the art of structural engineering for over 50 years. He participates in the conceptual design phase with architects to help assure their vision is achieved. Thomas is an honorary member of AIA Dallas. He has received recognition throughout the AEC industry for his creativity in development of innovative structural systems and for his pursuit of excellence in structural design. We've been friends, I think, now for 40 years, and though we haven't collaborated together, we've admired each other's work over the years. After the panel discussion, we will hear from Tyler Sprague. He's a structural engineer and historian in the Department of Architecture with an adjunct appointment in civil and environmental engineering at the University of Washington. He earned engineering degrees from the University of California, Berkeley, and the University of Washington, and worked professionally as a structural engineer for a number of years before completing his PhD in architectural history in the College of Built Environment at UW. His research investigates the intersection of architecture and structural engineering through a variety of methods throughout history. His book, Sculpture on a Grand Scale, The Thin Shell Modernism of Jack Christensen, was published by UW Press in 2019. Tyler currently serves on the board of the Construction History Society of America and as president of the local chapter of the Preservation Advocacy Group of DOCOMO in Western Washington. Finally, our last speaker is Chantel Blakely. She's an architect with experience and practice in advanced studies in architectural history and philosophy. She's an assistant professor at Rice University School of Architecture in Houston. Current research and writing projects include a monographic study of the Italian architect and industrial designer Marco Zanusso, born in 1916, died in 2001, and a book on the St. Louis-based architect Charles E. Fleming, born in 1937, exploring the relationship of art, technology, and meaning in architectural design after 1945. I've had the pleasure of following Chantel's career since her time at Princeton in the late 90s, and I'm a great admirer. After Chantel's talk, Thomas Taylor and I will join her and Tyler on stage for a final panel presentation.
Tere. Hello in Estonian. Dear guests, I have a small request to you. Would you please raise hands, those who are not architects nor engineers? Majority, that's great. I'm so glad that we are not having only a specialist symposium here, so that we can have a larger cultural discussion. I have a couple of disclaimers to make. My background is in the humanities. You could say that I don't know anything about architecture nor engineering. Nevertheless, I've been doing research on structural engineers and their collaboration with architects for more than 10 years. Today I'm going to speak briefly about some of the findings in relation to the legacy of August Komendant. My lecture is not going to be too academic. It's more like a slideshow, and I don't have a prepared written text. Let's see how it goes. My task today is to give you a brief picture of Komendant and his career as a structural engineer. First, I'm going to briefly explain his expertise and show very different projects from different eras. In the middle of the talk, I will focus on his projects he did with Kahn, and if there's any time left, I'm going to briefly dwell on his values and design philosophy. Yep, this is him. Probably around 1980. In the background is the Habitat 67 apartment building in Montreal, designed by Moshe Safdie. Komendant was Safdie's primary structural consultant for this project. Here's a view of the exhibition we did in 2020 at the Estonian Museum of Architecture, with original materials not only from Estonia, but from Philadelphia, from the University of Pennsylvania, which keeps the August Komendant collection donated to the university in the 1990s by Komendant's children who were introduced and now present here. Last year, we finally managed to finish the book. If you are interested more in August Komendant's work and career, try to Google it. There should be some copies on Amazon left. The print run was really small. I think 1,000 copies were printed. But now, August Komendant was not a German. Some authors have erroneously written that he was a German. No, he wasn't. He had a close relationship with Germany and German engineering. From 1929 until 1934, he studied at the Technical University of Dresden. He graduated as a structural engineer, and his speciality was reinforced concrete structures. He was remained true to concrete until the end of his career, and he basically didn't work with other structural materials. Some consider concrete to be cold and dull and boring, but Komendant definitely loved concrete. Early on, soon after his studies, he became interested in pre-stressed concrete, and the technology was emerging at the time, and he tried to implement it as early as possible. His second speciality, I would say, was precasting. After the Second World War, when he emigrated first to Germany and later in 1950 to the United States, he was very interested in the emerging precasting practice and helped to establish concrete plants even here in the United States. And in relation to that, I would say that the third strength and expertise in terms of expertise he had is manufacturing and construction in general. He was very interested in high construction quality and high level of delivering the actual built environment. So just briefly on what pre-stressed concrete is about. It enables to build stronger concrete structures. It also provides more economic ways of building, and it increases the aesthetic or the architectural side of structures. The primary application methods are pre-tensioning and post-tensioning. Pre-tensioning usually happens in concrete plants where concrete elements are produced. Post-tensioning is more common on construction sites after in situ concrete has been poured or concrete elements have been put together. They're connected with high quality steel cables, so-called tendons, and then put under tension depending on the particular necessities of each individual structure. The pioneers, we could list many of them, but I've added three on this slide: Eugène Freycinet, Franz Tischinger, and Gustave Magniel. Komendant knew of Freycinet's work from his studies and participated even some conferences in the 1930s where Freycinet was present. And with Franz Tischinger, he developed a very personal relationship. I'm not sure whether he attended his courses in Dresden, but later they even collaborated on one major project. After the Second World War, they designed what was, I suppose, a conceptual project for a large dam, a pre-stressed concrete dam on the river of Isar in Germany. Now I'm going to briefly introduce just selected projects. I'm not saying these are the best. Several true are one of his best, but just to give an overview of how versatile and diverse his output was. This military aircraft hangar is one of his first projects he ever did as a practicing engineer. After his return to Estonia, he worked for the Ministry of Roads. This building is still there, and this is possibly the first structure in Estonia where pre-stressing was used. This is a sectional drawing. I'm going to see whether the mouse works. Yep, it's somewhere here. At the bottom, you can see this gray line. This is a two-layer concrete floor, and inside the bottom layer, pre-stressing tie rods, as they are called, were placed and put under tension with huge wrenches manually. This is possibly the most important work of Komendant from the early part of his career, the Kadriorg Stadium grandstand in Tallinn. You can see contemporary photographs, it's still there. I went to see the Estonian track and field championships just a couple of months ago. Just great to be here. Great to be there to see the building being used in its original function. The small image is Komendant's drawing for a publication which depicts the rebar scheme for the cantilevering grandstand. The cantilever is about 12.8 meters. To continue, now we come to the United States of America already, and I mentioned concrete plants. This is Lakewood Pre-Stressing Company's plant in Howell, New Jersey. It was it was formed by the Estonian men who were hoping to be successful. Unfortunately, it didn't work out. Komendant also lost a lot of money he placed in the plant. But what is remarkable is that he designed the whole layout of the concrete plant, including all individual casting beds, office buildings, and necessary equipment. Most of it were built, and on the right-hand side you can see one of the casting beds with a beam inside it. Here is an example of precast elements on which Komendant worked. The cold storage and distribution center, unfortunately demolished, but in Secaucus, New Jersey. Here another one, his only project he did together with Eero Saarinen. Saarinen's structural engineer Henry Pfisterer approached Komendant to help figure out how to calculate and design the Firendale, almost like a fan-shaped roof structure for the Ezra Stiles and Samuel Morse colleges. So if you haven't been there and can get access, it's a remarkable space, or two spaces. Another great example of precast concrete is the Philadelphia Police Administration building in Philadelphia. And as preservation architect Jack Pyburn has addressed, this was almost completely built of precast concrete, one of the first buildings in the United States to use that large amount of precast concrete. On the left-hand side is a relatively small image of the structural system. You could compare it to a three-dimensional jigsaw puzzle or a Lego kit, a life-size Lego kit put together of factory-produced concrete elements and put together using cranes on the construction site and then post-tensioned together to create one structural unit. Habitat 67 was one of the most ambitious projects Komendant worked on, built for the 1967 Expo in Montreal. Here is a very early, beautiful rendering by architect David Reinhardt, who worked both for Kahn and later for Safdie. It's like an Blade Runner scene from the 1960s. It was built in a somewhat different form, but Komendant helped to figure out not only the, let's say, stability and structural functioning of the building, but also the whole production process of how to build a concrete plant on the neighboring site and how to deliver all the concrete elements to the site. Based on his experience with Habitat and some other projects, in the late 1970s, he developed a system, a modular building system called CASE system, probably Komendant system. And this is possibly the only patent he gained from the US authorities. On the left-hand side is the structural scheme for the system. Now we come to Lou Kahn. I can already realize that I'm in time trouble. They met in 1956 and worked together for 18 years until Kahn's premature departure in 1974. They taught together at Penn. Kahn invited him to teach master-level architects in his design studio. So Komendant taught architects about structures. They collaborated on 16 projects. 8 of them got built, and 6 are proper Komendant projects. Here's a list of unbuilt projects. Of those, I would highlight the Kansas City office building. These are Kahn's drawings. On the right-hand side, you can see the construction principle of this project. Komendant suggested to first cast using sliding formwork the corners and the cores of the concrete skyscraper, and then start building from the top towards the bottom, casting the floors towards the ground. So basically it's possible to build from top towards the bottom, almost like defying gravity. This is Komendant's drawing for the upper part of the building. Another one is a famous Palazzo dei Congressi project. On the right-hand side, you can see Komendant's drawing for the preliminary proposal. There were at least two versions on two locations. Unfortunately, this structure remained unbuilt. Regarding the built projects, I would say that 6 are proper Komendant projects. I will briefly show images of each of them. But the Erdman Hall in Bryn Mawr College and the capital of East Pakistan, now Bangladesh, is where Komendant's involvement was only episodic. The first major project, the famous Richards Medical Research Laboratories. Here is Komendant's preliminary design for the Firendil truss, a key element for the structural system of the building. This is the construction process, and here some additional images. On the left-hand side in the bottom, you can see pre-stressing with a hydraulic jack. Tribune Review building. This is Kahn's quite late rendering or drawing. And this is Komendant's drawing for the pre-stressed roof beam, which you can see here. The Salk Institute also had 2 major phases. On the right-hand side, the upper image depicts the section of the initial project with folded plates and box girders. The bottom image is of how it was actually built, again using Firendil trusses. And this is Komendant's Firendil truss. This is how it's on the right-hand side under construction. What's actually going on inside concrete is remarkable. Ordinary visitors don't realize how much technology is actually being put inside concrete structures. It's just when the building was being finished and after the completion. The first Unitarian church, particularly the roof structure, the folded plate, the Olivetti Underwood factory, for which Komendant helped develop the so-called mushroom module, or the prismatic shell structure standing on a singular column. And the last major project, and I would say the highlight of Komendant's and possibly Kahn's career, the Kimbell Art Museum. On the left-hand side is a beautiful drawing by architect Marshall Myers, who worked for Kahn for several years and was closely involved with the Kimbell project. This is a drawing already shown by Professor Nordensen, but this scan is from the original. It's not a copy. The final structural set is kept by the Alexander Architectural Archives in Austin as part of the Preston Guerin Drawings collection. Had the opportunity to see the originals a couple of days ago. Just amazing. This is the construction process. On the right-hand side, you can see the post-tensioning cables just before the shell pour was being done, and the building, how it was completed. I'm going to show you a couple of video clips. Actually, these are audio clips. Yeah, I'm out of time, but I'm still going to show the videos. It will take 3 minutes. The first one is 2 minutes And this is the only recording that I'm aware of where Komendant speaks. It's from an interview from 1985 done by a Venezuelan architect, Oscar Tenrero, with whom Komendant worked after Kahn's death on several occasions from 1976 until the end of Komendant's career.
I believe Kahn. We had the same philosophy. Practically, we had no disagreement about the philosophy. We dreamed together, we built together. You see, he was full of ideas. And whatever was the advanced design, he was interested, very much interested. When many people told, no, it cannot be done, for example, Kimbell Museum, nobody has used cycloids because it's very difficult to handle mathematically. They all said no and advised Kahn to use another approach. We came together and it was interesting and let's do it. We did it. So was also Olivetti building. Practically also Sol laboratories. You see, and it always worked out because we had the attitude, both. The structure is the integral part of architecture because that is the architecture. That's the oldest building we designed with Lou. It's structure. What else? But arranged in this way that it became architecture, balancing masses, areas, and always keeping this in mind that the building talks to you. Self, very clear, simple, nothing artificial. You see, Kahn told the same time to Eero Saarinen. You see, it doesn't take time when one knows how to do it. One has to, I have learned from my university days, this, I never used cat paper. All this computation, they are original. I never make a line, which I have to raise, sell the map. I never start designing when I have everything what I am using ready in my mind. And also I have the ability, right or wrong, when I see the image, I always see the finished structure in my mind.
I hope we can continue the conversation. If you are interested to contact me, go ahead and Google or go to the Estonian Academy of Arts webpage. Caitlin Müller will be next. Thank you so much.
Good morning. Thank you so much for inviting me to join this fascinating conversation. I'm so excited to be here and share my perspective. Like some of you perhaps, or maybe like none of you from Carl's question, I'm someone who's for a long time been interested in both architecture and engineering. And in my own career, I've always wanted to have it both ways. I've always wanted to be the architect and wanted to be the engineer, and repeatedly have been told it's not possible and you have to choose. And some of my mentors advised me when I was a student that I should look at this pairing, Kahn and Komendant in particular, look at this building to learn more about examples where the two have come together in such graceful and surprising and amazing ways. And so I'll share my perspective on this collaboration in this building that's really been both influential in my own career and inspired by my own perspective as well. One thing to know about reinforced concrete or pre-stressed or post-tension concrete before we start. When I was in architecture school, before I studied engineering, I was taught that we should admire concrete because it is massive, solid, monolithic, pure, one thing. When I moved to engineering school later, I learned it was the opposite. There's never concrete by itself. Concrete needs steel to work, to make buildings, to make architecture. Steel reinforcement provides the tensile resistance needed that concrete lacks. And I think I like that metaphor for architecture and engineering too. Architecture and buildings, the idea that they're pure, monolithic, singular, is a misreading of a much more complex story where the steel, the internal structure, the tensile reinforcement is critical, not only optional, but is the only way that this works. And I think this story also, for me, is an interesting way to think about that metaphor. So of course, we all know Kahn, and I've been grateful to learn about the career of August Komendant and learned so much more today from Carl. I believe this drawing was done by his daughter, Marika, who's here in the audience. This is from the archives at the University of Pennsylvania. What an interesting pairing, similar in age, both from Estonia. Komendant is a little bit older than Kahn. Oh, sorry, no, I said that wrong. Komendant is here a little bit younger than Kahn, which is unusual. Usually I find the engineer is a little bit older than the architect because it's hard to stand up when you're younger, but this is, we'll see maybe there's something about Komendant's personality here. One thing that's really fascinating and unusual about him is that he published a book about his experience working with Kahn. Those of you who are engineers, you may know it's extremely rare for an engineer to give their perspective on their career and especially on their collaborations with architects. The public prefers maybe or is used to the narrative of the hero architect and the supporting team. This book very directly subverts that narrative. It was published 1 year after Kahn died, and it is an incredibly fascinating and direct and specific book that goes through Komendant's version of the collaborations that they had together and makes a lot of very strong claims. You see the last quote, for example. When this book was published, again, 1 year after Kahn died, it was very well received, actually, in the architectural press. It was praised for providing a new perspective on Kahn's important career. More recently, it has been less well received, let's say, in some circles in art history. Many who study Kahn think Komendant is overreaching in the book or is overclaiming. And that itself, I think, is a very interesting story, that the contribution of the engineer has been perhaps intentionally diminished over the years, the 50 years since this project. And I'd like to bring it back to light. By the way, if you want to find this book, it is very hard to find, but occasionally you can get it for a few $100s in the used bookstores online, and if you can, I highly recommend it. This is an early sketch or an early concept for the Kimbell that was developed in Kahn's office, and this is some of the evidence we might look to for Komendant's claim that he was really played a really important role in the design of this building. You might notice some of the differences between what we see today and what the original concept was. We still had these long, extruded, beautiful linear roofs. Instead of curved in this cycloid shape that we know, we see this polygonal, maybe more pedestrian folded plate roof. And the other big difference are this arcade of columns that we know in the final building are much more infrequent. Komendant had a lot of issues with Kahn's fascination with the kind of Roman arch-like interpretation of this building, and many of his writings complain about this. Here's the final, a rendering of the final version, and you see I think the beauty of these long, uninterrupted expanses of these, what are called barrel shells in structural engineering that we're able to achieve. And here's the construction of these cycloid shells. The cycloid shells, as we've seen, are tensioned with these post-tensioning cables that follow lines of principal stress. They're quite remarkable and create this incredible spatial and visual experience on the interior. But the story that I want to show today is that the genesis of these shells cannot necessarily be attributed purely to Kahn or purely to Komendant. There's actually a much longer history and lineage of shells of this type that I would say culminate in the Kimbell Art Museum that have never been executed before or since with such incredible vibrancy and talent and skill and sort of cohesion. But the technology itself is actually much older than this building. They were not invented for this building, despite what we hear a lot from sort of the art history perspective. Kahn often wrote about the kind of connection to the vault and the sort of Roman sensibility of the building. And I think my reading of the book is that infuriated Komendant because These shells, although they have this arching shape, structurally, they primarily do not carry load down the curves of the arch to the ground. That's why there aren't any columns underneath. They carry load in the long direction. There are these long, uninterrupted spans that essentially work like beams. And so this is from Komendant's book, where he's saying Kahn's understanding, alas, was completely wrong and dishonest. One way to think about it, and this building is used frequently to teach students about structural engineering because it is so it's so iconic. The reason that the shells work structurally is because not necessarily anything specific about their shape, actually. It's the depth. So the shells are quite tall if you go in and look at them. And it's just like an I-beam, concentrating material sort of toward the top and toward the bottom of the structure gives them structural stiffness and allows them to span 100 feet. But there's a lot of amazement and mystery about this specific cycloid shape and this confusion with this Roman arch behavior. So this has been written about many times in structures textbooks for architects that know these behave as beams. They're these longitudinal kind of corrugated structures. There are other similar structures. This is Zarzuela's hippodrome in Madrid that was built years before with a kind of similar typology. Here, the bottom image shows the internal lines of principal stress and tension that inspired the layout of those amazing tendons that we've seen. So this, I think, remains an interesting kind of mystery of is this classical form, or is this kind of a good but not specific structure? A lot of important people have written about this question, including Guy wrote a beautiful essay about this topic in 20 years ago. And a lot of them have grappled with this question of the cycloid shell. The story that's pretty well documented at this point is, as I said, neither Kahn nor Komendant came up with this geometry. In fact, it was discovered by Kahn's associate Marshall Myers one weekend while he was kind of grappling with what to do with the Kimbell. He took down this book from his personal library called Surface Structures in Building, published by a German architect in 1961, Fred Ungerer, who had taught a one-year university class at the university where he was in Germany to educate architects about new technologies in structural engineering. And he had this very accessible, very nice book published in English where he went through some of the ideas of possible shapes for shell structures. And notably, you'll see here is the cycloid. So this is literally exactly what the Kimbell Art Museum is. It was plucked from a 1961 German textbook, which incidentally also is a fascinating shape. It's the cycloid, which is the path traced by a circle as it goes along the ground. In the same textbook, this idea of the long shell versus the short arch is explicated quite clearly. So this story has been kind of told and reinvestigated many times. But this cycloid was not invented, as I said, by either character. So where did it come from? How did Fred Ungerer know to include it in this book? The cycloid was a subject of fascination in kind of science and technology and the popular interpretations of them since the late 1800s because it was central to some of the science about planetary science and falling bodies. This is a really fun illustration in Scientific American for how to make your own cycloid at home. So if any of you are inspired, you can do this when you go home. And I think because it was a mathematically well-defined geometry, there was a lot of engineering that then kind of went in to support it. It was well mathematically described, and as we'll see later, then some engineering theory was developed to support how to understand it if it were carrying load in specific ways. But according to this beam theory that we just need a lot of structural depth to span a long way, there's nothing about the cycloid that's especially important. Franz Dischinger, the German structural engineer who Carl mentioned, studied the cycloid along with many other shapes in the context of what are called barrel shells, which is what engineers call the shells of the Kimbell Art Museum. This is a book, kind of a pre-building code from 1928 about concrete construction, where barrel shells are first illustrated. Here's a load test on a very early barrel shell, not a cycloid, but a different geometry with similar behavior. This is a really fascinating sketch. I don't believe this was built, but this was 1926. Look at the skylights in that long barrel shell. Do those look familiar to you? I find this fascinating that these ideas have been kind of recycled, and I doubt anyone from Kahn's team happened to see this, but these ideas had been in the water for a while. Komendant was familiar, actually, with these ideas, as we know, because of his education in Germany and his friendship and professional relationship with Franz Dischinger. They were both around the same place at the same time and both working in concrete structures and pre-stressing. This is his PhD, or sorry, no, his engineering diploma from Dresden, where he studied. After he came to the United States, as Carl said, he maintained this relationship with Franz Dischinger, who's often known as one of the fathers of shell theory, especially German shell theory. This is correspondence from the archives about the funeral, where Komendant and his wife were invited to this funeral. Another kind of thing that was in the water at the same time was an early textbook on statics and dynamics of shells in German, written by Pflüger in 1934, which includes a page where they describe the mathematics and the engineering mechanics of cycloid shells. So I won't go through this math with you guys. I barely understand it myself, but it is clearly laying out how to analyze a cycloid used in a barrel shell. And this is Komendant's copy of this book from the library, the archives at the University of Pennsylvania. I note heavy finger smudges on the page with the cycloid shell. And interesting to the quote, there's actually a lot of eraser dust in that part of the book. So there was a little bit of erasing. But clearly he was familiar with this book. This is another book published around the same time, also goes into cycloids. Komendant wrote what may be the first book in English on pre-stress cycloid shells. So this kind of understanding of this technology had been around. He also built some cylindrical shells himself, or designed some at least, before the Kimbell Art Museum, before Kahn. This is a project for a much more pedestrian building in Philadelphia. I think this is kind of an entry canopy for a motel with this cylindrical shell that he designed. There were some later books that started to bring this question of shells and their amazing geometry from the utilitarian functional world of engineers to the formal and spatial world of architecture. These are two of them. But it remains a bit of a mystery how this trajectory happened. I think it's really a coincidence that Komendant was in this German world of shells from which the cycloid emerged, but it was Marshall Myers and Fred Angerer's book that led to the specific geometry of the Kimbell. So it's kind of an amazing story, and this confluence of engineering theory, form, and space. Komendant, of course, was also familiar with this general idea. He was a master of this idea of using thickness, structural depth in folded plates and corrugated shapes to achieve long spans in spatial conditions. So he was very familiar, and I think Marshall writes that when he proposed the cycloid to Komendant said, yeah, we can do that. And of course, he knew how to do that from his long history and from these textbooks. And he designed this particular cycloid beautifully with these incredible post-tensioning strands. To me, the story is really interesting because there's no hero. This is not about a single genius who invented something new, although the Kimbell, of course, is in many ways innovative and unique and singular. But it's the result of these lineages and these interactions and this international kind of transfer of knowledge and inspiration that makes this building amazing. And I think that story is often true but untold for many of the pieces of iconic architecture. A few other interesting things about the structure. A lot of people have worried quite a lot about these incredible skylights that are what give the space its illuminated, incredible otherworldly quality. This is a sketch, I believe, from Marshall Myers from the archives also at Penn during the design of the process, where he's extremely worried that they have removed the keystone of the arch to create the skylights. He's like, oh no, how will the arch stand? The keystone is critical. But of course, as we know, it's not an arch, right? It's this long beam that happens to have this curved shape. And so many people have written about this, about whether we should be worried. In fact, of course, we don't need to be worried. And in fact, there's structural connections that I'll show in the next slide that connect across those skylights every 10 feet with a steel tube to help the whole structure act together. This is another project that I mentioned, the Zarzuela Hippodrome in Madrid from 1941 by Eduardo Torroja, which has a similar shape but an opposite module. So it has a cantilevering, what's called a gull wing, like this shape. And some people have postulated that perhaps that's the module of the Kimbell, and that maybe has architectural implications. Is the module the space or the form? From an engineering perspective, I'm quite sure it's this one. It's the space. Partly because of the way the structure behaves. So because it's simply supported, the bottom part is in tension, the top is in compression. So the part where the skylights are being pushed together, they're susceptible to what's called lateral torsional buckling. And so that connection across the skylights is really important, and that module is really important to maintain stability. So if not the cycloid shape, which Komendant kind of claims in his book, but I think Komendant did not invent the cycloid shape, but undeniably contributed in extremely fundamental ways to the excellence of this project. I think we'll hear some more about these details from some of the future talks, but I think it's the overall cohesion that he contributes to from his deep understanding. It's the incredible finish that Guy mentioned of the interior of the shells that came from his decades of experience working with this material. It's this extreme integration of structural ribs thickened on purpose that also integrate the mechanical ducts. It is the lunette window with the shaped beam diaphragm at the edge that creates that incredible tapered appearance. It's the removal of columns, absolutely, that creates this expanse and this confounding experience of cross grain in the interior of the space that we see here. And so I think the story is both undertold and understood, but also perhaps not quite knowable. There are so many of these interacting parts that lead to this success that it's really not just this one building, but it's this years-long relationship that was at times very contentious, but also extremely close, that led to the excellence of this building. Here's this lunette window that I think we'll hear more about from a future speaker, where the tapering of that structural beam on the edge, that thin structural beam, was apparently demanded by Komendant because the bending moments at the top of the diaphragm are highest because it's keeping the edge of the cycloid from opening, but also creates this incredible visual and architectural thinning of the window itself. I think the understanding of Kahn and engineering is something that continues to be debated among historians and critics. This is another quote. This is Abatur, who's another wonderful engineer who worked with Kahn and who had this quote, "You engineers are all the same, you're like sausage cutters." And I think Guy referred to this idea as well. I think the best engineers, of course, are not. Abatur's beautiful analogy is as a dancer who's supporting another dancer who are working together to achieve something. I think Komendant absolutely falls within this spirit. The last thing I want to say about this before we move to the discussion is about the process that was used to design and engineer this project that in the context of history, was perhaps the last of its time. Because Komendant had this incredible education and this extremely deep knowledge of the 8th order differential equations needed to engineer these shells, he referred to the mathematical challenges of them. We could not design this building today the way that Komendant designed it, or at least most engineers could not. We don't teach engineers these methods anymore. All of our analysis today is done on the computer with finite element analysis. The particularities of a shape are both no longer concerning, but also no longer enlightening. And so we can take any shape and put it into our software and find the deflections and stresses and find a safe way to design it. But we would never, I think, achieve exactly this because we no longer have that process. So I think that's another really important and undertold significance of this building, that it represents the kind of pinnacle of this 20th century trajectory of engineering innovation, mathematical theory, and architectural excellence that can converge to create this incredible piece. Thank you very much.
I think for those of us who have spent time studying the building over the years, we learned a great deal that we didn't know. It was really inspiring. Tom, do you want to start with any questions?
Well, I do have a question. With a a little small commentary that goes to the question to explain why I asked kind of a simple question. We spent a lot of time, rightfully so, talking about the design aspect of the dome, the post-tensioning and the cast-in-place concrete. And we also talk about the fact that he did it by hand and with a slide rule. And I started it in that era, and I'd have told you it wasn't possible, except I came here and saw it. So those are two kind of important ingredients. I actually believe that the hand calculation and the slide rule is a better engineering approach than the computer. But the question that I'm leading to is, this is absolutely a beautiful architecture, and it's also a beautiful structure, one and the same. And in your book, you talk about the SALT Institute, about Komendant himself being out there guiding and supervising and showing and leading the construction workers that were pouring the concrete. And this concrete worries me a little bit if I was starting from scratch and I didn't know that it could be done, that it's only 4 inches thick, and it's got full of welded wire mesh, full of post-tension tendons, and it's so thin, and yet it's so beautiful. And the craftsmanship is good. I was here years ago with an architect, and his comment was, well, our craftsmen today couldn't do what they did. And I really think the difference wasn't the craftsman. I think the difference was Komendant. And so you haven't mentioned what his role was on the construction of this building. And I was just curious, because to me that looks like a very difficult part of the process that hadn't been really focused on heavily.
Where should I start? Maybe from the 1930s. Komendant had his own small construction company for a time. So construction sites were something very, very familiar to him. And as an engineer, I would say he was oriented to building. Robert Le Récollet, for example, was a very different engineer. He was interested in a theoretical kind of conceptual approach to structures. But Komendant wanted to get good ideas built, to materialize them, to bring them out to the society so that they could benefit from those great spatial ideas. And detailing and the construction quality was something of utmost importance to Komendant.
Yes.
And sure, you can say that he was almost like a control freak. But in order to get this result, on several occasions, he was on site almost. It's a strong pedagogical statement, I would say, that an engineer who knows how something should be comes on the site and kind of guides and teaches the construction workers. So he took great care of when buildings were born.
Well, I guess, Guy, my only point is, and I'll let you talk about it, is that the structural engineer's role that doesn't stop at the end of turning over a set of drawings, and particularly when you're going to build something like this, what's missing today is Komendant, except Guy, what you did here. But anyway, that hasn't really been focused on as much as I think it needs to be, in order for us and our era to replicate something similar, is how we work with the craftsmanship.
Caitlin, did you want to add something?
Yeah, no, I totally agree. That's a wonderful point. And I'm just reflecting that we happen to be sitting here in this beautiful room with what's called architecturally exposed concrete, designed by Guy in his office, is incredibly unusual. So the idea is very appealing, that the structure is the architecture, and that's it, and it's authentic. And if you hear that, you say, oh, yeah, well, yes, of course, that's what we should do. That's almost never done today. It's extremely rare because of exactly this point about craft and coordination and commitment to execution, that you can't just cover it up later with a finish. You have to be committed at every point. And the structure goes up first, right? So after the structure goes up, when all the other things have to happen, that has to be protected, that has to be respected. It's different than the kind of most expedient way to build, which tends to be how we do things today. So I think for many reasons, this is exemplary, and I would advocate for more of this type of work where we see the structure exposed, both as a student, it's amazing, it's better environmentally, it's less wasteful, it's more beautiful, I think, but it's very rare, and it's different than the way we work business as usual, I think.
I mean, from the experience working on this building, but also studying and listening to your talks, I think you're recognizing the importance of craftsmanship, which in the end is a matter of relationships, that the design team amongst each other, and I wanted to ask a little bit about integration of other parts of the building, but being on site means developing relationships with the craftsmen and the builders, and creating an environment, which I think Kahn was particularly good at doing as well, where everyone is committed to getting the results that you're describing. In this building, there were many, many people involved in getting to the point where the concrete quality was what it was. Larry Eubank, who was a big part of that, can attest to this. And those of us involved can remember all the little specific steps and details and people. But in the end, it's a kind of commitment and leadership that does start with the architect, that makes sure that everybody is constantly paying attention to the importance of this result, and then ultimately a client like the Kimbell backing that commitment up. So I often use the term that Ezra Pound used to use a lot, describing these particular moments of history where, as he put it, there are these vortices where talent, commitment, attention, craftsmanship come together, and this is clearly an example of that. I was curious, you showed the section of the building that, I think Caitlin, you showed the section of the building with the mechanical system, the lighting. We didn't talk much about that, but how did you feel in the research that you've done? What did you see was Komendant's engagement with those other disciplines? How much conversation was there between him and the designers of the mechanical system or the lighting designer? Can you talk a little bit about that?
Yeah, my understanding is that it was he was quite involved, which is also very unusual. So, they were negotiating on centimeters or inches of how deep the edge beam would need to be, and then what size ducts were able to fit in between. Same with the light, the natural light fixture or the light reflector that creates that visual effect. Is also this incredible dance between the structure and all of these other pieces. So I think that's another physical manifestation of this integration that I think was rare then and is extremely rare today, where it's kind of like designing a car, right? You have the chassis, that's the structure, but you also know what the outside needs to look like, and you have almost no wiggle room for all the parts in between. Buildings are not, again, designed that often to have that tight integration, but the original Kimbell absolutely was. I don't know enough about how contentious that process was. I get the sense that there was some arguing and some energy invested in getting all of that exactly right, but I think it was worth it, and I'm sure Carl knows more about that.
I'm not sure that I have enough information to describe the, let's say, everyday involvement of Komendant. Sure, he went to construction meetings during the process. What I do know is that he always wanted to keep the structure pure, so to say, that the structure and the structural logic of the building would be visible, so that in case of the Olivetti factory, for example, he was, like Kahn was sad, but Komendant, I think, was almost furious that the lighting and the installations, they basically hide all the structural beauty inside the building. So one thing what Komendant demanded is that, be it exterior or interior, that all the installations should be adjusted in a way that the structure is not hidden. The principle of structural honesty, which was quite popular in the modernist context, was something very, very dear to him.
Tom, did you want to add something?
Well, I guess, you know, we kind of maybe all have the sort of the same thoughts, but I think you said that Commandant was quoted as saying nothing artificial, and that's the same as integrating the structure and the architecture. And this building is probably the best example in this part of the country of seeing the structural engineer and the architect work together to integrate structural design and architectural design in one, integrated. There's nothing artificial here.
Well, I mean, in the case of this building, it's also built on a relationship that Renzo Piano had with the mechanical engineers at Arab, who, you know, many of whom, Alistair Guthrie in particular, worked over many decades. So there is a quality to buildings like this that follows from relationships that, you know, like Kahn and Komendant, or Peter Rice and Renzo Piano, that the trust and communication and common language that gets formed over many years of working together gets translated into that kind of close fit that you see in the physical. I was wondering also, when you made the list of the buildings that they worked on together, that doesn't include all the buildings that Kahn was doing at the time. No. So somehow there must have been a moment at the beginning of every project where Kahn thought, am I going to work on this with Komendant or not? Do you have any insight into how those choices were made?
Just a little. These are things that are not necessarily documented that well. Sure, there is some correspondence, and you can see some notes on design drawings or preliminary drawings. But my impression on, at least on a couple of occasions, that it was not necessarily Kahn, but it might have been his engineers who felt that they need an additional advice for this or that project. But sure, there were projects, for example, the first Unitarian church, where Kahn and Komendant discussed the very fundamental questions of what a church or what a church hall should be. So Komendant on several occasions was involved in the dialogue regarding the general architectural concept. But yeah, as I said, this is something that is often not documented. You can read from the memoirs that Kahn and Komendant had drinks together, but and in another place, Komendant described that, yeah, I mean, the decisions were basically made behind those drinks. You can't see the birth of an, okay, in terms of architecture, you can see an architect thinks when he's making sketches, but in terms of these kind of discussions, what was later put on paper or calculated in static calculations, this was just a kind of next step to the fundamental decisions which were done or decided early.
You've mentioned a couple of times the other engineers that Kahn worked with a lot, Keaston Hood. And I think one of the parts of the story that's important is the collegiality and friendship that they had with Komendant, that they were very free when the time came that they thought, gee, we really should bring him into this project because he could help. I mean, that's as part of this also is the relationship between engineers that occurs.
In that sense, Komendant was a true consulting engineer. He was interested in the hardest problems. He didn't have a large design office. He just wanted to, and often in his later career, dealt with the most difficult questions. Yeah.
I also think it's the specific expertise in concrete that he learned during his, and contributed to during his training in Germany was rather unusual in the United States. So if you contrast with Eero Saarinen, who was working around the same time, he didn't have a Komendant. And in some ways, the results are kind of evident. In some ways, Saarinen made some structural mistakes that get, redebated in the critical literature every so often that Kahn managed to avoid through working with this really leading expert who brought this specialization. And the other engineering firms at the time in the US, I think, didn't necessarily have that expertise.
We could talk about that.
I'd just like to make one comment sort of about all this. I almost feel like there ought to be a class at the university about how to communicate with an architect and how to, if you're going to be a structural engineer designing buildings, your role basically is to accomplish the architect's vision. And that's kind of rare, actually, in our structural engineering profession. There are a handful that understand that, and there's different ways that you can learn how to do that if you want to, but I think that's a role model, and he had that relationship with other architects as well. And so many structural engineers don't really, one of the things that we do with a brand new architectural client is to get the books and read the books and see what his architectural desires are and how he likes to design and get a little bit of a better feel for a new architect. But I think that's a very important thing that Komendant did with his clients that is not a course at the university. So,
speaking of university, I like your comment about the difference between the mathematically based analytical tools that Komendant used, which were closely tied to the clarity of the geometry, that you need to be able to describe the geometry analytically in order to do those calculations. And then where you're an expert and a pioneer is in the digital tools that we all use. Can you elaborate a little bit on that difference, and should we be going back to hand calculations as elegant as Komendant's, or?
I hope everyone's ready for a lot of differential equations if we if we do. But yeah, it was a really interesting. Those of you who are practicing engineers, and maybe some of you, like Tom, did practice during this previous time, but it was a very different way of thinking. We were constrained by the geometry that we could express and represent mathematically in equations. And it happens that the cycloid was one of those shapes. And then some really brilliant engineering theorists came up with the equations to describe the internal stresses and displacements for those very specific shapes. And so we had a highly constrained palette with which to work. Is that good or bad? I think we can debate. There were many things that were good about it. It led to a clarity and a simplicity and an ability to elevate craft because we weren't noodling on geometry. The geometry was set. In our modern era of digital tools, we are much more free. We can represent any geometry we want with quite a lot of precision with modern CAD tools. We can also simulate any geometry we want with a lot of precision. We can also throw steel at any geometry we want. And that's how many buildings are designed today. It's this one-way process. I think, to me, we have not reached the pinnacle, and in some ways, yes, that's a descent maybe from this high point in the mid-20th century. But I remain optimistic. I am a person who develops and advocates for digital approaches to design. What I see as possible is to capture some of the elegance of these hand calculations through abstraction, through thinking about simplified representations of design and engineering, which are also possible on the computer in more flexible ways. So we don't necessarily need to have a 10 million element mesh to analyze a conceptual design in architecture. We could think more straightforwardly, but also more flexibly about geometry. We can find new forms that weren't possible with hand calculations. But I think we need to return to some of the, not necessarily simplicity of form, but simplicity of thought in order to allow us to have this iteration and back and forth. We've kind of gotten ourselves into a corner right now where we have these giant, mega powerful tools that can only be chained together in series. And what I really admire about this process was because of the simplicity, it allowed a much more flexible way of thinking about design.
May I add something to Caitlin? I think, if I got it correctly from you, is that we have to think about, not about what is possible, but what is appropriate. That we can do a lot of things, but like Kahn and Komendant together had extensive discussions. What would be an appropriate architecture and structure related to this architecture for a particular building, be it a church, an art museum, or a housing project. For quite a long time, we've had, especially reinforced concrete structures, for more than half a century. We can build almost anything, but is it always reasonable what is getting built? Is it appropriate in a deeper sense?
I think that's a good segue for our next speaker. So thank you all.
Thank you.
Is the mic on? Coming in. All right. Thank you. Well, it's wonderful for me to be here today. My name is Tyler Sprague. I'm an associate professor at the University of Washington. I have a position in both the Department of Architecture and Civil Engineering, so like others that you've heard spoke today, bridge both worlds. And it's really such fertile ground for understanding buildings in a new light, as both technical and aesthetic, as both material and space. So I am not an expert on Komendant or Kahn, but I have done a lot in this time period all about reinforced concrete. I am a structural engineer, and that's central to my point of view. I practiced for several years before shifting back towards academia and earning a PhD in architectural history. So I really do balance a practical understanding of structural engineering with a perspective on history. I also bring a West Coast perspective. So I'm native to the West Coast, educated at Berkeley, out in Seattle. So I often gain a perspective of looking back east. So much of our conversation has been about the East Coast and Europe, but I think by having a perspective from the West, from the coast, offers something new here today. Long been fascinated with the creative work of reinforced concrete, as I said. Concrete modernism as a medium of design that's material, structure, construction, technology, labor, and certainly, as we've heard, the Kimbell Art Museum is a shining example of this. A carefully detailed, ambitious, yet restrained structure that transcends any separation of architecture and engineering. Trying to find the line where the structure stops and the architecture begins is futile. The 16 shell vaults create both external form and interior space, provide order to the program. They manage gravity and light in powerful and subtle ways. It's truly remarkable. So today, what can I offer? What can I say that hasn't already been said? I want to place it in a bit of a comparative context and talk a little bit about this mid-century period, about American modernism, and specifically this idea of a concrete modernism. For as much as we've highlighted Komendant works, we know he's within a larger field. There are other engineers that are out there. As Professor Mueller was saying earlier, the technology of concrete shells developed over time, and Komendant relied on this work that had come before him, as all engineers do. Hardly anybody is making it up on their own. And in concrete modernism, there's always collaboration between architect and engineer, especially in the United States. It's very rare to find individuals that are working alone on these projects. So this is certainly true of Kahn and Komendant. They worked together. We can at least say that. While their working relationship was certainly fraught, the quality of their shared work is undeniable. right? The conflict, the power struggles, the disputes of authorship and missed deadlines, all of that came together to produce truly stunning work. And so most of what I know about that relationship comes from this text, 18 Years with Architect Louis I. Kahn, and we get Komendant's clear perspective on his contributions. To summarize the book, he did it all, right? That's basically the takeaway. And as we said, written a year after Kahn's death, we'll never get the counterpoint or the other perspective. So with our focus on Komendant today, we are gonna roll forward with some of his quotes. So he says, at one point in this contested process, Komendant says, when I accepted the role of engineer, I sent a letter stating my acceptance, provided that I would have the authority to make decisions concerning the design and that these decisions would be honored by both architects. Wow, that's a lot of power in that statement, right? So it certainly is appropriate to bring Komendant's contributions to the fore, to discuss the building on the terms of structure, keeping in mind this collaboration which was inevitably there. So following Komendant's words, we can get into some of the specifics. I do like getting into the details here and pulling out the particular elements of the project that really make it shine. It's all about synthesis and shape and light. This image certainly speaks to the repetition that's present on this project, an architecture of repetition, 16 shells, so they're all of cast in place, reinforced concrete. Komendant tells us they were built on only 2 sets of forms. So the formwork that was built was lifted into place. The shells were cast. Once the concrete is cured, these forms could be lowered, moved over to the next bay, raised up again, and simply reused. This was a strategy of economy. It's quite expensive to build that formwork, but it also creates a repetition of ideas and detail and form and space, where a single item can be focused on very intensely, and then through its repetition, its slight variations with courtyards and conditions, you begin to appreciate the singular element in a new light, right? So focusing on this individual shell, we can go even more into some of the details, so I'm tamping down some of my engineering ideas with the numbering and things here, but there's specific elements I want to highlight, which I think will really help us compare the shells to others that are happening at the time. So of course we have our shell geometry, the cycloid shape, roughly 23 feet wide. We have this edge condition where the shell terminates on this edge beam, or as Komendant would call it, a marginal beam that runs along the shell. We have its span, so it's roughly 100 feet between columns, and the long dimension making it act, as has been said, as a beam and not an arch. We have the end condition. How do you finish the shell? We have this thickening, this curved stiffener, this tapered, greatly shaped, and then of course the end panel that fills it in, and of course the post-tensioning, or these draped strands that exist within the shell. So I'm grateful to come at this point in the day when you all have heard these things once before, and we can bring them forward, right? But of course it's the synthesis of all these things that make it truly remarkable. It's the highlighting of silence and light, 2 important words for appreciating the mutual work of Kahn and Komendant. So I want to also say how these elements that we identified earlier can be traced to earlier projects, to other projects, to a designer that I'm more familiar with out on the West Coast. They can be used as points of comparison, right? So I'm going to introduce another individual, another protagonist in our conversation. So this is the architectural engineer Jack Christensen. So Christensen was a prominent American designer of thin shell concrete of a variety of different geometries. He is of Danish and Swedish descent, but was born in Chicago, educated at the University of Illinois in architectural engineering. Early on, he was inspired by the work of Robert Maillart. He got to know people like Anton Tedesco, had a strong sense of structure and space. He was never taught shell design, but picked it up on his own. His work was less conceptual and more practical. He liked to build. and completed over 100 thin shell concrete projects in the US on his own. So he becomes a useful individual to compare some of the work that we see here at the Kimbell. Christensen did design a variety of geometries, but today we'll talk about a single curvature vault and see how his trajectory overlays with the work here at Kimbell and produces fascinating insights. So I think we'll be able to both appreciate the Kimbell in a slightly different light and also build appreciation for other thin shell projects that exist here in the United States. Though practicing mainly in the Northwest, Christensen was nationally known as a partner in the firm Skilling, Helle, Christensen, Robertson. Alongside Les Robertson and John Skilling, this was a powerhouse engineering firm from the 1950s through the 1980s, made most famous by their collaboration with Minoru Yamasaki and the twin World Trade Center towers. They designed a variety of projects with incredible complexity and known for their collaborative spirit with a variety of different architects at the time. And shells were part of the firm's profile. So John Skilling was the salesman of the group. I was interested to learn that Thomas Taylor had a personal memory of working with John Skilling on some projects here in Dallas, and he left us with this quote that we had to be dreamers to do thin shells in the 1950s. There was no one to tell us what to do. We had to work out answers for ourselves. This pioneering didn't make us any money, but taught us what we need to know about thin shells. We developed our concepts intuitively, analyzed them, and designed these structures conservatively. This is published in Engineering News Record around 1964. So you can see engineers like to say they're making it all up on their own, doing it all themselves, right? It's a common theme that's coming out here. But it's certainly shells were part of their process. Right? So we'll go back to the start of shells for this firm. It really can go back to a single book. Right? This is the ASCE, American Society of Civil Engineers Manual 31, comes out in 1952. And this is a textbook, or it's a design guide that allows for a simple definition of the parts of a barrel vaulted structure of a specific geometry. So these are cylindrical shells. So they are not cycloids. They have a constant geometry. So a single point and a radius comes out, sweeps, and you get this part of a circle that is your shell. This guide took analytical solutions that had been developed in Europe for shell geometries and adapted it to a table-based engineering method. So you could use simple proportions to find out how big you wanted your shell to be. You could read across the line and get your stresses and your forces that you needed design for. So this simplified the design method for shells greatly. And Christensen found this guide just as he was beginning his career in 1952 and was immediately taken by it. So you can see his hand calculations here where he's understanding the blending of structure and space that shells offer. It's both a curved structural section, but it's also enclosing, and he makes this a big part of his practice moving forward. So onto the shells. So this is his first one. This is the Green Lake Pool in Seattle, built in 1954. It's considered an intermediate shell because it is both arch and beam. It's wide and long, but given the radius and the proportions, it has both types of behavior in there, and the design guide simplified that. Right? So we have a span here of 110 feet, slightly longer than the module here at Kimbell, but it's much wider, and it's just a single shell. Christensen learned early on that the cost of these shells was in the construction of the formwork. So while it was a successful project, he couldn't believe to see this massive amount of formwork built only to be thrown away at the end of the job. And we can also see one other element of the design here on the drawings, which is this deep beam. So while the shell itself is roughly 3¼ inches thick, we have over a 3-foot deep beam here tracing the edge of the shell to resolve all the forces that exist at the edge. Right? And this becomes an important part of the evolution of shell design moving forward. On his next project, he works with the architect John Maloney to design a school warehouse building where we have a repetition of shells. And here we see the emergence of this architecture of shell construction, not just a structural shape. We have, this is actually an early drawing of 2 spans back to back. So there's a line of columns down the middle of significant span, 130 feet. We see here the first time the use of a reusable, movable formwork system. So like Komendant, Christensen used just 2 sets of forms that could be used over and over again to cast multiple shells, with concrete being relatively expensive and only a small amount of it needed for the shell. Once the forms were built, the cost of adding additional shells was very low, and they quickly found that they could easily expand the warehouse. They had a contractor had the rare occasion of having leftover budget, so they added more bays out of the existing formwork for only a minimal amount of cost. And while we do have a warehouse, we have elements of architecture that are coming in, right? We can see the extension of the column beyond the face of the building, the slight extension of the shell as well, revealing the thinness of the vault beyond. We can see that horizontal window, which tells us that end panel is not actually bearing, right? It's not a support for the shell up above. We see the door. So we see elements like this start to come into the design, and it's here we see this conversation of concrete modernism really take off. Right? Christensen continues to evolve this design and include new techniques. So we have a shell construction here at a high school, again in eastern Washington, right? A pretty rural place, but we see changes to the architecture. We see the full height window and the introduction of a curved stiffening element here at the top, now allowing full height light into the space. We can also see a slight camber or bow to the structure. So it's not only curving primarily in the one direction, but in the long dimension, we're also seeing a little bit of curvature there. And that's due to the introduction of a new technique, right? Or at least Christensen claimed it was the first time it had ever been done, right? So here we have the first pre-stressed edge beams in the United States. Claims like this are made to be overturned, so I welcome any sort of evidence to the contrary, but we can see we have post-tensioning ducts here, and we see a line of cables embedded not in the shell, but within the edge beam of this vault. And here on the drawings, we can see the jacking force indicated there, right? Wonderful drawings, again, from the same time period. I don't know if you all are starting to appreciate these like those of us do, but they are really wonderful artifacts of hand work. These are obviously scanned, but these are hand drawings that are including things like formwork and, of course, end conditions. And the gentle shaping of structure that you see here really comes through in the final work. So on the interior, it's a bit dark, but you can see these beams that go between columns are starting to get smaller. So the introduction of pre-stress means that we no longer need that massively deep beam. Our whole shell structure starts to get thinner. Right? And of course, this is making national noise. So whenever we're out in the Northwest, we have to wonder, are we doing things sort of out on our own? Is anybody taking notice? But of course, Engineering News Record is indicating they know about this work in thin shells in the Northwest. And it's just 2 years later that the National Architectural Forum proclaims the rise of shells. So 1958, here we have the full arrival of concrete shells as a part of an architectural modernism. And most modern architects of the time are dabbling in this medium. Christensen keeps designing and finding new architectural collaborators. So this is with the Seattle-based firm Nairmore, Bain, Brady, and Johansson, now known as NBBJ, where they continue to advance this concrete modernism. This is a gymnasium space for a high school in Seattle, where we see the introduction of yet another technique, which is claimed to be the first pre-stressed edge, shell, and edge beam in the US. So this is a beam, 1958, where we see, like Komendant, the draped ducts of post-tensioning tendons within the plan of the shell. We also still see the post-tensioning of the edge beam as well. So we have 2 lines of cables, one above the other, all with the effort of reducing the profile of our section and giving us a lower profile vault, right? And again, we can see this as sort of an intermediary step. They're working things out. We go from no post-tensioning, just the edge and shell, and so we have a natural evolution to get to post-tensioning within the edge itself. And we're getting some long span space, and we're getting an architecture that comes with it, allowing light now with a much reduced edge beam, right? Great for a gymnasium space. The Pacific Northwest is building like crazy at the time with a huge demand for schools, so a lot of Christensen's shells do exist in this type of setting. As I said, Christensen is a part of this larger shell community. So in 1964, he's on this American Concrete Institute panel with a lot of names that those of us that are in the field will recognize. So there's Pfluger, who I think had an author of a text that Professor Mueller mentioned. We have David Billington, we have Felix Candela, and we have Jack Christensen right below. We also have Mario Salvatore, John Skilling, and of course it's all chaired by Anton Tedesco, right? So this is sort of a who's who of designing shells. We do not see Komendant's name on this list, but he's clearly a part of this engineering community. These are the people that he knows, and this is the conversation that's happening around his designs. And so Christensen's work in cylindrical shells really culminates in an absolutely massive project, not in the Pacific Northwest, but down in New Orleans with the New Orleans architects Curtis and Davis, also known for their work on the Superdome. This is a convention center along the banks of the Mississippi where they look to Christensen for a massive gesture in concrete shells. So here we have 6 shells, but they are 60 feet apart, 60 feet wide, with a depth of 18 feet, and they span an absolutely incredible 253 feet plus 139. So what does that mean? That means we actually have a 2-span condition. We have a set of columns on one side, sorry about that, columns in the middle, and then a massive vaulted space to columns on the outside. And you can see in this drawing, we really have a shaping and a real architectural treatment of this same cylindrical shell. Right, we have an edge beam that's turned up. We see the gentle tapering of the overall form. This was almost described as like a humpback whale existing on the banks of the Mississippi, or the waves of the Mississippi coming through. Here we can see them under construction, massive amounts of formwork to create these types of vaults. And right in here, you can see these draped post-tensioning strands. So as an evolution of Christensen's work in structure and in this concrete modernism, we see the full integration of these post-tensioning ducts only within the shell. This, in effect, is a project that has no edge beams, since the shells come together and come to essentially a point. So they all taper together in sort of a deep V at the union of these two shells, right? Christensen was awarded a national award for his design on this from the consulting engineers. And you can see in this poster sort of the thinness of this profile, right? It is still an incredibly thin concrete vault, right? Giving its own architectural treatment. So we have diamond-shaped columns that accept the flowing nature of these curving vaults. And this itself is just a symphony of cast-in-place concrete. This building was demolished in 1995 and no longer exists. Replaced with a casino. And here it is from the inside. You can see that we have almost a total elimination, like I said, of that separate edge beam where those shells come down, and to give you almost a seam between those shells, with, of course, the hidden post-tensioning strands within doing all the heavy lifting, carrying the vaults. Right? And that brings us back here. That context sets the stage for how we see so much, or how I can see so much of Kimbell and the conversation that's interesting to have. We can notice things like the gently tapered edge stiffener, right? We can notice, of course, the span. And we can notice the marginal beams, those elements between the shells, right? And Komendant was very particularly interested in these details and specifically these beams. So when asked about the marginal beams, they were requested to be oversized by the mechanical engineers. And he said, no, let's not make those bigger, sort of contrary to the evolution that we just saw. And even Kahn was confused. Isn't it so that the beams are carrying the shells? And Komendant says, no, on the contrary, the cycloids are carrying the beams, right? Which leads us to a similar place of the post-tensioning within the shell is doing the heavy lifting, and that beam that runs along is less a part of the structure than that post-tensioning that we see, right? And we can even see that in the construction photo, that those beams were built before the shells. They remain shored underneath. So we have a cold joint between the casting of those marginal beams and the shell up above. And Komendant describes this in order to establish a stable and firm base for the construction of the cycloids to get the geometry right. The corner columns and marginal channels of the shells were constructed first. So they come in and they're shored up, and then the shells are cast over top. And the specifics of how they work together continues to be fascinating, right? But the shell is doing the deep work. They're joined to those beams, coming together to give us the final shape that we have here, right? So there's a history to these details. There's a context to the architecture that we appreciate here. There are questions that remain, but that's the exciting part about being in this field, is you get to understand these buildings on different levels. We get to take them apart, put them back together, understand the pieces, how they work together, but all part of this really fertile field of a concrete modernism that really defined a lot of American architecture at this time. Great, thank you.
Good morning. I guess it's the last few minutes during which that would be accurate. I'm delighted to be here today and to talk to you. I'm an architect by training, but currently practicing as an architectural historian, not as an engineer. And this topic brings me outside my nominal area of specialty, but perhaps many of you have had an experience where something that you have done, some work that you have done, has been done. You've seen someone else take credit for it. I certainly have had that experience. And when I began to be acquainted with the story of Komendant and Kahn, I started to wonder, as an architectural historian, about our culpability or our implication and how that has happened. So that's what I'm going to talk about today. In the standard story about the Kimbell Art Museum, the building is portrayed as the work of one man, Louis Kahn, for the most part. It's often referred to as one of his greatest achievements, but strictly speaking, as we've heard, Kahn did not design the building by himself. His collaborators included Preston Jaron, Richard Kelly, Marshall Myers, and Harriet Pattison, architect and landscape architect in Kahn's own office. The contribution of August Komendant, the structural engineer, included the design of the roof and associated structural system. His design work is visible right on the building's surface. So it's surprising to learn from his memoir that in the original publicity about the building, his name was omitted. Komendant was offended. He withdrew from any events related to the building, and when he wrote his memoir, he said he had not been back to see it. Human error may explain the omission of Komendant's name from the first news items about the building, but it's harder to explain the omission in critical writings about the building. For example, architectural historian William Jordy, assessing the Kimbell for Architectural Review in 1974, commended and named the lighting designer and even the fabricator of the lighting elements, but did not mention Komendant at all. A roof is not the whole of the building. The design project here included the plan, the multiple levels, the sequence of moving through the galleries, The relationship of interior and landscape, choice of finished materials. The project encompassed all of these and more elements, and the coordination of all of them, too, is crucial. But it seems to me that there's a blind spot in how critics and historians of architecture, like myself, are trained to look at architecture. The accounts of buildings by historians and critics are prone to operate on the premise that the architect is the sole, principal, or ultimate creator. These accounts play a crucial role in shaping the public perception, not only of specific projects and their particular creators, but also of architecture itself, and of the value of architects and engineers and their roles that they play in constructing the world around us. So, what can we do about this? Can the scope of the historian extend to encompass the points of view of many contributors? Can we acknowledge the visible traces of both architecture and engineering decisions and see something positive, even in their difference? I think we might have to change our relationship to some of the basic premises of architectural history and criticism, which have to do with the identity of the architect as an artist. One, that the architect is a singular author or creator, and the other, that the work of architecture is actually a bearer of messages from this individual. Kahn quite famously embraced the artist identity. He devoted himself to articulating his aesthetic ideals in public speeches and published writings. In his 1969 lecture, Silence and Light, for example, he said that the self, the mind, and the body amounts to an instrument of expression. The problem faced by the architect is to learn how to use this instrument in a precise way. So there's an implicit parallel to music. And Kahn spoke also, when he spoke about ideas in that speech, he said it was important to let an idea come into being and to not be concerned at first with whether it works or not, I quote. Kahn was not the only architect of his time to project a strong self-image as an artist-creator. He was like Le Corbusier and Frank Lloyd Wright and others in this respect. And the idea of the architect as artist and creator was pervasive in major histories of modern architecture. The idea that the architect was an artist and creator who worked on social themes partly by applying his individual gifts. And also this parallel between the architect and the artist. So, for example, Siegfried Giedion in his Space-Time and Architecture described an exchange of ideas between architects and cubist painters at the origin point of modern architecture. And meanwhile, Nikolaus Pevsner, in his 1936 History of Modern Architecture, portrayed Walter Gropius as the inheritor of a distinguished aesthetic and moral lineage in his book Pioneers of Modern Design. And this also image also was reflected in popular culture, and it was not a new idea, this notion of the artist. Herbert Reed, the British critic, found its roots going back as far as Plato. So in writings about Kahn and his buildings, it's not surprising that these underlying assumptions are tacitly perpetuated. They continue the pattern of Pevsner, Giedion, and other historians of modernism. They reflect an ongoing close association between architecture and art, and between the architect and painter or sculptor. For example, the account of the Kimbell by Patricia Clemmings Loud, an art historian who had a special role here at the Kimbell as curator of architecture, is the definitive account of the building. Her narrative of the project in the book, The Art Museums of Louis I. Kahn, is comprehensive and definitive. It's widely quoted, it's cited in many subsequent writings about the building. And in its sensitivity, its meticulousness, and its thoroughness, it's a model for writing about buildings. And part of the way that it achieves this is that it brings together different kinds of information about the building. It provides abundant background information, describes the new institution that the building was intended to accommodate, introduces the client representative, Richard Brown, and his curatorial project lists the client's priorities and introduces the architect, lists the architect's other projects, a sort of curriculum vitae of the architect, so that the Kimbell could be understood as one in a series of works by the architect. And with respect to the project itself, her narrative provides a detailed, illustrated chronology of what happened when, shows images of the design in various stages, and reconstructs the evolution of the plan and site plan, and not least, it traces the emergence and individuation of prominent features such as the roof structure. And among the many illustrations in the book is this sketch in which Kahn first characterized the galleries in terms of a series of parallel vaults. This sketch appears in every article I've read about the Kimbell Art Museum, and it's actually quite evocative of the qualities of the interior space and the overall configuration between these parallel vaults. So these component presentations in Dr. Loud's text on the Kimbell create a framework in which we can come to appreciate the building in light of the architect's many decisions and the problems along the way, and we can understand how the design responded to the client's wishes, how, as the project developed, the building established a communicative relationship to the city and to the public and the visitor, and how it served the client's cultural ambitions. And it's a thrilling account to read, partly because it keeps us focused on Kahn's design intentions as a kind of through line of development around which all of the episodes in the project's history can be organized. So behind this work is a history in which for hundreds of years, art historians and curators have expanded our capacity to engage artworks by artists with many different kinds of intentions by interpreting them, which is to say, by telling us what paintings or sculptures or other artworks mean, and how that meaning is conveyed by the work and by parts of the work. One example of how this method is taught today, it's called close looking. The object is considered, and the features of the object are noted and matched in some sense with aspects of the context of the work. The context might mean who commissioned it and why the commission was made, what they asked for, in fact about the painter, the relationship between the painter and the patron, and so forth. So to take an example, like Fernand Léger's composition here at the Kimbell, we might notice the seeming combination of two-dimensional and three-dimensional shapes, the use of color, but then the forms that appear to be perhaps metallic, the suggestion of architectural forms, of letters, and so these become the sort of building blocks of an interpretation that might, as in the case of the notes that accompany this painting on the website, make reference to Léger's interest in cities, his fascination with the phenomena and the stimulation and the intensity of life in the city. In an analogous way, Dr. Loud's account of the Kimbell Art Museum building and the accounts that are similar of other architectural historians encourage us to notice parts of the building, and to observe how they align with some aspect of the context of the project, such as a theme or a function or of interest to the architect or the client. And it's part of the attention to detail in this work that this account includes sketches, including sketches by Kahn on the upper left, the sketch by Marshall Myers of the cycloid, or it's actually more of a drawing, that sketch I referred to before, and sketch of the building itself, and even also Komendant's sketch of or drawing of the cycloid as the designed cycloid from the structural engineer. But while it's not exactly dismissive of Komendant, the narrative nevertheless affirms a hierarchy in which, as we've heard in the previous talks, it was Myers who thought of the cycloid, and Kahn, and it sort of gave it to Kahn to put it into this big process of Kahn resolving the design. And Komendant figures in this account as sort of the structural engineer having validated and sort of designed the shape, the structural shape. In other words, he emerges as a kind of oblique figure. And this contrasts to the story that Komendant tells in his memoir. And again, we've heard a little bit about this story before, but an important aspect of it is that Komendant describes ongoing, repeated conversations with Kahn in the course of design, which is different from a kind of structural design that simply makes the idea work, which is what the way art historians, unfortunately, tend to think about structure all too often. I'm particularly struck by these exchanges in which Komendant, that he describes, in which Komendant would convince Kahn about the correct way to detail part of the building. He describes moments in at least two projects, the Tribune newspaper building and the Kimbell Art Museum, in which Komendant had to convince Kahn about the right approach to the architectural form. And the sketch that Patricia Loud and William Jordy and other architectural historians refer to as evidence that Kahn conceived of a building section very much like the one that was built. Also, this sketch also appears in Komendant's memoir, only there, Komendant tells of seeing a misconception in the sketch. He describes it as being full of errors. For example, it shows light fixtures that are hanging from the surface. And to Komendant, this suggested reading the form as the arch, where the forces are carried by the side walls, and so can hold up these supports for the lights. And it isn't so much about the weight of the lights not being supportable by the beams. It's the fact that it's actually not an arch, it's a beam, so it would be dishonest to treat it as an arch. So this was the gist of Komendant's, the point that Komendant had to make to Kahn. Komendant's insistence on the honesty of the project in this sense did not just have negative outcomes dissuading Kahn from one design decision or another, but also a positive outcome. And an example of this is the shape of the lunette, or the arc of glazing, and you've actually also seen this a few times in previous talks in this panel. The arc of glazing that appears beneath the roof element, which you can see in the drawing on the right. Here it is. There it is in the drawing. Komendant describes that he convinced Kahn to show the shape of the cycloid in this elevation detail, which one sees from the inside and from the outside. The cycloid, I guess it's the edge piece of the cycloid tapers toward the ends rather than create an iconic, an arch, a smooth arch form, which would fulfill the iconic purpose of representing the arch and the Roman motif that was so important to Kahn, but would have been dishonest by hiding the fact that that shape is actually a cycloid. And the result that we see here is, in my opinion, one of the building's most expressive details. It's a detail in which the architectural idea and the structural idea are both visible and fully integrated. And to my mind, it must be viewed in two ways, corresponding to the 2 points of view, not only the point of view of the architect. A detail like this one demands something more than the paradigm of the architect as the artist and the building as the message from the artist. We need something more like a two-message model. I have to say that I don't think we should abandon that idea of the architect creating the space, because personally, I find it very interesting to experience the building that way. Perhaps we just need to add to it or have access to another way of reading it as well. Because to think about two authors, it carries with it the idea that, well, the idea that there is just one author. It necessitates thinking of all of the collaborators as somehow supportive of that role. And that is one way to see it. But in our society, in the way modern buildings are built, it requires the input of many professionals. And so each of those professionals typically will have a sense of serving the public in a way, so let's say, parallel to that of the architect. So to see this building from more than one point of view, to celebrate those details that express that multiplicity, is really to kind of do justice to the modernness of the Kimbell, to what makes it different from simply a Roman-like set of arches. And this is, there are many stories that I think merit examination and measuring against how we do, I think we should reconsider how we do architectural history in light of stories like this one, Komendant's, but also with respect to collaborators within Kahn's own firm, such as Harriet Pattison and in other projects, Ann Ting, and surely other people in Louis Kahn's office as well, who had done design work that would eventually be folded into one of Kahn's projects. So, drawing from Komendant's book, I propose that we should see this image, we should see in this image the arch and the cycloid superimposed. So the arch form, here is the smooth shape that could be the icon of an arch, and we can see that, we can find that within the elevation. But then the cycloid form is actually quite different, with the two narrower points at the end and the thicker part at the top, which is the point as well. And as I understand, it's something that Komendant insisted upon, that different thickness and thinness be visible. So we can see that as well, in fact, in the shape of the lunette, which is wider at the bottom, mirror, it is the consequence of expressing the shape of the cycloid. And there they are, superimposed in the design. So in the history of optics, there are, of course, optical illusions where we see, for example, a book that might look open or closed. But the concept I want to put out there for further reflection is the aspect, which is to say something a bit richer than a simple trick of the eye, reflecting how we see. And this was something of fascination to the philosopher Ludwig Wittgenstein, who wrote in one of his books about seeing aspects. When we see something, we don't simply take in the image of it the way a camera captures an image. We bring something to what we see, and what we think we see is an outcome of what we bring to seeing what we see. Wittgenstein's example for this was the duck rabbit, this figure you see on the left, which actually you could see it as a duck, that is, as the head of something like this, or you could see it as a rabbit as well, and yet it's just the same thing. And this is how I would like to think about that motif in the elevation, that it is this two-aspect thing. The arch refers me, and I hope my students, to Rome, which might conjure something like the Romanesque barrel vault in the Church of San Vicente, or the tabularium in the Roman Forum, and of course the basilica, this public space building type in Rome, would also be a reference here. Whereas on the other hand, the cycloid conjures images of the great engineering achievements of the 19th century and 20th century, where the sheer need of scale or span meant that the display of the engineering shape, the structural shape, was unavoidable. Or indeed the Tallinn seaplane hangar, which I'm told is not a cycloid, but an Estonian, or a project built in Estonia that has an extraordinary span and spatial concept. The building, the Kimbell, belongs to both of these lineages, and we see it all the more clearly in the way that this window detail is expressed. And I also don't think that this would need to take us away from the idea of an association of architecture with art, because in the late 20th century, there were also artists who explored in their work the tension between free artistic form and shapes that are determined by some kind of necessity. So that is where I will end. I think, as I said, I think the Kimbell is perhaps one of the most projects of among their collaboration in which that collaboration is most clearly expressed, but quite possibly there are others as well in which a similar evocative detail may be found. Thank you.
Well, thank you very much for those great presentations. This has been a thrilling morning and early afternoon. So I can't resist asking you about the Yakima High School, because it leads into a question that I wanted to ask. So it reminded me of Barbie.
The movie or the doll?
All of it.
All of it.
So
Okay.
why is it so pink?
So-
Why is it so pink?
Oh, so I think that was a washed out image that
Ah.
came through. No,
I
not
thought that
not
was
a
the
pink
building.
concrete or a statement about,
Not pink concrete.
no.
That's too bad. So I think the question I'd just like to put out there, related to both of your presentations and particularly Chantel, to what you were referring to, is the lack of a critical framework that allows us to discuss these relationships, not just between the structural engineer and the architect, but between parties who make a clearly important and creative contribution, right? It's not like everybody on the team is playing the same role. And you mentioned the word hierarchy. There are relationships that some are leaders and some are contributing. And it seems to me that we have models, in particular in film, where we have a critical framework that has been around for a while, that allows historians, critics in the press to highlight creative contributions. My friends among architectural critics will point out that it's more difficult in buildings because you don't see many of the parts that contribute. But I think that can be overcome, as you've shown, all of you today, in your research. So maybe to provoke a little bit of the conversation around that, is it because in film there are labor unions, as we see the screenwriters striking right now? But, you know, there's an Actors Guild, there are various organizations that represent the different participants that have been reflected, if you think about it, in the Oscars, which are a mirror of those organizations. So, you know, what is it that we're not doing in this field that would both highlight contributions, but also maybe enable a more equitable relationship between the participants? So that's where Barbie comes in.
I see. Yeah, and you're absolutely right. There are so many contributors to buildings, and it just strikes me that there are so many histories yet to be told. There are certain histories that have been honored through disciplines like architectural histories with entire curriculums and architectural histories. Structural engineers do not have that. You go to a school of engineering and you are not offered a 3-course series in the history of engineering where we highlight the contributions of individuals, see the evolution of thought and technology, and celebrate that lineage as part of the practice of engineering. There's a lineage of contractors, individuals that bring their creative contributions through their work. And so one of the powerful things I found with Jack Christensen was tracing his work as an overlay to all the different architects he worked with. So he worked with Yamasaki, he worked with Curtis and Davis, he worked with NBBJ, a flurry of modernists in the Northwest, but there's a through strand to his projects, the ones that he's on. You can see a creative voice coming out, which is not to say that the lineages of the architectural, process are any less significant, but that there's another story embedded there. So finding ways to lift up the stories of the individuals that contribute. We still are in a very sort of individual, not I'm saying individual, like contributor-based field. So there are people that bring their knowledge and expertise from one project to the next. And following that is a really powerful way to start to bring out that story.
I think it raises an interesting question about the political and the psychological. Because the labor union is like a form of political action. And I think in order to respond to, by that means, is to like sort of force, to leverage, we'll use leverage to, make it appealing to the person in power to do something differently. And it doesn't have to do with the discussion of the content at all. It's just sort of purely pragmatic. But then on the psychological side, I think there are certain biases that get played out when, for example, if we think we're looking at the work of an author, let's say a writer, my favorite example is J.D. Salinger. Like, you don't necessarily think about his editor. Although if you then go to the archive actually and you look at like J.D. Salinger's stories before they were edited, you don't recognize the writer at all. So you realize that the editor played a huge role. And yet there's something about looking for the author that precludes our noticing, or even we resist believing that someone else is involved. And I think something like that is at play in architects versus structural engineers. And part of it is that romance of the architect, which I have to admit I'm completely susceptible to as much as anybody else. So I'm conflicted. I guess if I could just add one other thing, culturally, I think maybe it's Western culture, there's a sort of bias against utility. Of course, in some of the old architectural treatises, there's utility, beauty, and firmness are part of architecture, but this idea that the architect designs something beautiful and the engineer makes it stand up, it's like that goes way back as well. And I think it has to do with how we think about things that we use, which we don't usually see while we are using them, as opposed to artworks, which are all about our seeing them and not using them. I'm not sure why that might be the case.
I think I want to elaborate on something I said a while ago, and then make a statement that as structural engineers, that our responsibility, our goal is to meet the architect's vision. And when you see how Komendant did it, he met the architect's vision by improving the vision with the structure and exposing the structure as the architecture. So he had a philosophy that I think is somewhat lost a little bit. And the most important thing for me today that I think you've accomplished, and I hope that there'll be a continuation of this, this is really the only Komendant example in this part of the country, and you don't hear that name much, and as time goes by, you might hear less and less. And yet, on the other hand, what he did years ago philosophically is what we should be learning how to do today as structural engineers and architects. So I really want to thank you for that because I've learned a lot today, and I'm so delighted to be here and to see his name brought back to life again so that maybe we can capitalize and learn from that.
Thank you. Do you guys want to bring up any questions or topics before we close?
So it's just wonderful to have the opportunity to have this discussion. You know, my personal history seems to be a lot about uncovering this and finding the venues where this is appreciated and understood. And the Kimbell is certainly a place where, like I said, the separation between architecture and structure is impossible to make. So it's such a wonderful example of that hybrid work. And I would encourage everyone to celebrate both the utility and the beauty in the things that they appreciate, that there's a method to design and there's multiple collaborators. And so pulling apart all the things we love about Kimbell and highlighting them here today has been a real pleasure to be here.
I would just end by encouraging everyone, if you haven't, to go over and see the exhibit about the, I guess it's the 50th anniversary exhibition over in the other building, which includes some very amazing drawings, including some of Kahn's sketches from when he was traveling in Greece, and a drawing by Harriet Pattison with Kahn's notes on it, another kind of layer of collaborators folded into what we see. And yeah, it's quite amazing to have this conversation in a museum, and I hope there will be more conversations about architecture and engineering. Thank you, Guy, for organizing.
Well, as someone who's thought about this and read and written about this over time, it's really inspiring to hear all of your presentations today. It's really encouraging to see you doing this work. It's necessary, it's uncommon, and so thank you all very much for the excellent presentation and the research that went into it. Thank you.